A lot of students get confused at this point on the difference between the standard deviation and the standard error. And if you just go to Google and type in, what's the difference between the standard deviation and the standard error again, you'll see a lot of results from people who have the same question. There's a really great set of statistic notes that were published in the British Medical Journal by two guys named Bland and Altman, and their article on this is one of the most popular hits. So look at the BMJ for statistics notes. And this is actually a good supplement for a lot of the stuff that we'll be covering in this class and in any future statistics class that you take. But let's review briefly. What is the difference between the standard deviation and the standard error again? Now, the standard deviation we use to describe the spread. We usually use it to describe the spread of individuals. We can think about women in the US and the average height with shoes, average reported height with shoes might be, say, 5'7". And there might be a standard deviation on that. Let's say it's 2. So maybe that's 5'9", 5'11", and so on. When we talk about individual people in a distribution, if it is normally distributed, we can describe those people by the mean and the standard deviation. So here, you could say, hey, that standard deviation is about 2. 95% of the people are within 2 standard deviations of the mean. Now, if this is a sample of women, let's say this is a sample of 100 women, what do you think the population of women looks like? Well, the population of individuals and the sample of individuals is going to look pretty much the same. Imagine you had a variable that had a big positive skew and was long-tailed right, like that. What would a sample look like from that population? Well, a sample of individuals from that population is also going to look long-tailed right. It would be a distribution that's not normal. So when you think about individuals, if we have a normal distribution, we can use the mean and the standard deviation to describe their spread. Now let's think about when we're talking about the behavior of means. And again, this is a weird concept because it's based on what if you had theoretically, hypothetically, spent your whole life repeatedly taking samples over and over and over again, what would the distribution of those means look like? Well, you wouldn't get the same mean every time randomly. The means would bounce around a little bit, and that bouncing around is described by the standard error of the mean. And again, that's driven by 2 things. What is the spread of that characteristic in the population? And what is the sample size that you're repeatedly taking over and over and over again? Now, this leads us to a really interesting point. If you're trying to take a sample to see what's going on in the population, you might raise your hand at this point and say, Tibor, how would I ever know what sigma is if sigma is supposed to be the standard deviation in the population? And the answer is, of course, you don't, because you don't know the population. So what you often see for the SEM is that you plug in, what is the standard deviation of my sample divided by the square root of the sample size? Now, can I do this? Can I plug in the standard deviation of my sample as an estimate for sigma? And I think we can say, well, yeah, because we just saw that a distribution of individuals is going to look like a distribution of individuals in the population. So when we talk about individuals, we use the standard deviation. And when we talk about means, we use the standard error of the mean. What's confusing here is that the standard error of the mean is the spread of the means. So the standard error of the mean can be thought of as the standard deviation of the spread of the sample means. And I know this sounds like gibberish, but go read a few articles on this, talk to a classmate, email me, talk to a TA, and make sure that this this information is cemented in your head. Because when we go forward, it's going to be really important to know whether we're talking about a statistic or whether we're talking about individuals. And we're going to build off of everything we've done to talk not only about the behavior of means, but also to talk about the behavior of other statistics. So for example, proportions. What percent of people have a given characteristic? Take a sample, ask them the yes/no question, and then put a confidence interval around it. Then we're going to see, what about if we have two different populations and we want to see if they're different? What if we have two different populations and we want to see if they have different means? Those are all statistics, numbers that describe our sample, and we can put confidence intervals around them. So stay tuned for that and make sure you're firmly cemented on what is the difference between standard error and standard deviation.